For example 5, we are using the rules of logarithms to expand and simplify. My first one, log base 5 of x squared y to the 5th. This multiplication, when you expand it, it becomes an addition. So log base 5 of x squared plus log base 5 of y to the 5th. From there, I'm going to use the other property, the fact that when you have these exponents, they can get multiplied out front. So that 2 gets multiplied out front, 2 log base 5 of x, and this y to the 5th, that 5 gets multiplied out front. So plus 5 log base 5 of y. Part B, log base 3 of x cubed plus 7 over 3 to the x. There is no property that involves adding of arguments, adding or subtracting. So that first part I can't really do anything with. I have to keep the x cubed plus 7. But the division I can expand. So log base 3 x cubed plus 7 minus, because of the division, it becomes minus log base 3 of 3 to the x. I can expand this a little bit more by bringing this x out front. So I get log base 3 x cubed plus 7 minus x times log base 3 of 3. But because this base and that argument are the same, this is just 1. So it's minus x times 1, and we can write a cleaner version of it. Part C, the same thing. Inside that square root, I have two different terms, so I'm not going to be able to separate that in any way there, but I can get rid of the exponent. So first is that multiplication becomes an addition, so ln of e to the x plus ln of x squared minus 4 to the 1/2 power, because that square root, we can write that as an exponent. Bring this x out front, so I get x ln of e plus, I'm bringing the 1/2 out front, 1/2 ln of x squared minus 4. This ln of e, the same thing, that base is e, and the argument is e, so that's just equal to 1. So I get x times 1 plus 1/2 ln x squared minus 4, which is just the x plus 1/2 ln of x squared minus 4. For example 6, we're going to go in the opposite direction. It's already expanded. I want to put it back together. First thing I need to do is bring back up the exponents. So I get log x minus log of y squared. And then when you have that subtraction, when I put it back together, it's a division. So x over y squared is the argument. And we get log of x over y squared. For B, again, I have to take care of these exponents first. So ln a squared plus ln b squared. And then put it back together so that addition becomes back to multiplication. And now I have this single logarithm. So I had mentioned in the first part that these logarithmic and exponential functions are inverses of each other. And one way to show an inverse is by just graphing the line y equals x, which is this line, and flipping it over, right? So it's just going to be reflected over that line. So here's my y equals e to the x, and here's my y equals x, and then if I just reflect it over that line, I get the y equals ln of x. I'm not going to have you sketching the logs, but I did want you to see what they look like. The properties. The domain is from 0 to infinity. The range, negative infinity to positive infinity, are all real numbers. It passes through the point 1, 0. Just like in the exponential, it passed through the point 0, 1. So these are just flipped. It's continuous on 0 to infinity. It is increasing if b is greater than 1. And it's always decreasing if b is less than 1. So here my base is a half, and this function is always decreasing. Here my base is 3, so it's greater than 1, and then you have the function that's always increasing. So some properties. We have e to the ln x is equal to x. Just like when that base and the argument were the same, that was just like a 1. So what happens here is e to the ln of x is just going to equal to x. So these e and the ln functions cancel each other out. And ln e to the x is also equal to x. And we're going to use that when we're solving equations. So that's why these properties are important to go over. And then the last thing I have for this is solving a couple of equations. So I'm going to do it out. It is in your notes. But I wanted to show you step by step. So 2 times e to the x plus 4 is equal to 9. I always want to isolate. So I'm going to divide both sides by 2. And I get e to the x plus 4 is equal to 9 halves. And then I want to get that exponent out. So I'm going to take the natural log of both sides. And the reason I'm taking the natural log in particular is because this is e. And this is base e. So those two are going to cancel out. So I get ln of e to the x plus 4. Well, I can bring down the x plus 4 in front. And ln of e is just equal to 1. So I get x plus 4 is equal to the natural log of 9 halves. And then just subtract 4 from both sides. So that's the exact answer. And I'm going to plug it in my calculator. So hopefully you can see this okay. What do we have? We have natural log. So here on my calculator is the ln button. That's base e. And above it is the log button, which is base 10. So I'm working in the natural log. So I'm going to hit ln of 9 divided by 2. And then close my parentheses and minus 4. And I get negative 2.496. I'm going to leave it as. And then another example I had is 12 ln x plus 7 is equal to 0. So I need to again isolate this. So first thing I'm going to do is subtract 7 from both sides. So I get 12 ln x is equal to negative 7. Then divide by that coefficient. And I get natural log of x is equal to a negative 7/12. I want to rewrite this as an exponential. The base here is e because it's natural log. So e to the negative 7/12 is equal to x. Okay, so now I'm going to again put this in my calculator. So I have where that natural log button is. If you can see above it, it's the e to the x. So I hit the second function and then the natural log. So I get the e to the x. And I need to put in a negative 7/12 and close my parenthesis. I use the fraction key. And I get 0.558.